Previously, we have seen that this table produces a relationship that whenever we enter any number to it, if we would have that number multiplied by 15, or in mathematical terms, from x, we multiply to 15, the answer will be 15x. And this number becomes the partner of x in our ordered pair. So it's as if we can write xy for this to be very similar as x and 15x. We also saw another relationship wherein when we have x, it comes out as the number multiplied by 10, then subtracted 2. So if we will have our ordered pair x, we will have 10x minus 2. And as we might have noticed, whenever x goes in, there's only one y coordinate. We never saw that if we input an x into that specific relationship or that specific relation, it will come out with 2, 3, or more y coordinates. We only have exactly one y coordinate for that specific x coordinate. And this special type of relation is what we call a function. Formally, a function is a rule of correspondence that pairs each element in one set called the domain to exactly one element from a second set called the range. So if you would notice, the definition of relation is there. A rule of correspondence that pairs an element in one set called the domain to another element in the second set called the range. However, there are now some certain conditions for the relation to be a function. It should pair each element of the domain to exactly one in the range. Now, before we go further into the definition, like a relation, we can also express a function as a set of ordered pairs. Let us illustrate it. So we can write this as like what we've seen before: 115, 230, 335, 345 rather, 460, 575, 690. Now, do take note that strictly speaking, this is the only function, and we're not supposed to extend it to the next. Although we can guess for this specific ordered pair set, this is only the function. That means beyond the x values of 1, 2, 3, 4, 5, and 6, this function is not yet defined because all we know is this set of ordered pairs. We can also make it as a mapping like what we have seen. This is 1, 2, 3, 4, 5, 6. We can make our y here as 15, 30, 45, 60, 75, 90, and this is now our mapping. So this is also another way of representing the relationship. This is the mapping. The one here on top is our table of values. And we have also seen that we can actually represent this as an equation. So, we know that for this specific function, the x can be represented, not the x, but the y value can be represented as the x value multiplied by 15. So we can say that our y value, these y values, are equal to the x value multiplied by 15. So reading it as an equation, y equals 15x. And we can also represent the function as a graph, which we will look in a while. Now that we know how we can represent functions, let's now take a look more closely into its definition. What did the definition say? Let's say we have here our domain, and let's say here we have our range. In the definition, it says each element in the domain, there you go, in the domain. That means all of our x's in our set should be used. That's what each element in the domain means. Then the other important part of the definition, it should be exactly one element in the range or in the second set. This means that the x value can only be assigned to one y and one y only. So just like this one. Here, even though it's not a straight arrow, we can see that 1 is paired to 4, 2 is paired to 2, 3 is paired to 10, 4 is paired to 8, and 5 is paired to 6. And as you have seen, all x's are used. Each element in the domain is used. No x has more than one y. As you can see, the 1 only has one partner, 2 has only one partner, and so on. Therefore, this meets our condition, therefore this is a function. And that is what the definition of a function would mean. Let's take a look at another example. So we have here our domain and our range, and this is the relationship that we would have. Is this relation a function? Pause the video and try to think about it. So let's see if our conditions that each element in the domain must be used and the elements in the domain are paired to only one y. Let's see if this will be followed. So, as we can see, all the elements in the domain are used because they're all tail ends of the arrow. So that means this is correct. Now, the x values can only be assigned to one y. So as you can see, all the x values only have one partner. Now, sir, is it okay that their partner is the same? Well, yes, it did not say that the y value should be unique. Since it did not say that it would be unique, the partners of the x's can be the same because no x has more than one y assigned to it. Therefore, there we go. Therefore, this is a function. Let's take a look at this specific relationship. Is this a function? Pause the video and try to think of it rather. Now, this is not a function. Now, why do you think so? Do take note that our domain, one of the elements of our domain has two partners, 2 and 10. Because of that, we cannot have this as a function because it violates that the element in the domain should have exactly one pair in our range. Therefore, this is not a function. So we'll look at more examples of functions in the next video.